Lab 2. So the purpose of this lab is to compare the point charge and state line charge methods of charge tape. The useful formulas are going to be the same as Lab 1. So that's Coulomb's law, Newton's second law, specifically for gravity in this case. And then the Q of an electron. And the straight line charge model predicts that a single piece of tape has a charge of 2.78 e to the negative third coulombs. So these are the experimental results from Lab 1. I did not repeat the Lab 1 experiment, so we're just going to use this data. Length, mass of each piece. The distance between tape pieces is 8 millimeters. This is the first set of gravitational and electric forces. Let's see, and then other calculated data. Here's the charge of tape B, the electron deficit of tape B, or in this case it'd be both tapes, and then the number of atoms on sticky surface, the ratio, yeah. So for the coding, let's see, your typical defined variables. Here's the mass of the tape from Lab 1, as well as the charge that we find a bit later. Let's see, here is the definition of an electric field from Lab 0. And then over here, I messed around a little bit with the top and bottom tape axes just to make them a little longer, and then also to get the distance between them correct. And then the scale for the electric arrows down here. And then for part 2, we end up making the electric fields of the pieces of tape here, and then we get the force of that field, and then we just make arrows for them. So for comparisons and also the what if, so this is the straight line model. It predicted a gravitational force of 2.78 e to the third. So we ended up having to get that Q back here as close to it as possible, which ended up being 1.401 e to the negative 8. For the magnitude to be equal, which is a little bit bigger than the charge from the point model, which was 4.47 e to the negative 9. Let's see, and the assumptions for the straight line model were that the charge was distributed evenly, and also the same one atom thick tape. Let's see, and then as for why those two may be different, the overall electric field of the two pieces of tape depend partially on the shape. So if you simplify it down to a point, you change the electric field and you deviate more from the true electric charge than a straight line model does. The straight line model is also somewhat simplified because it can't take into account the thickness of the tape, and it can't take into account how many charges there are, but it does a better job.